Hi, this is Kevin Williams, Product Manager with JDSU Test and Measurement. Today I'm going to discuss measuring resistance with the JDSU HST 3000 equipped with the copper testing module. Thank you for joining. The resistance measurement is used to identify the presence of shorts and grounds on the cable pair. Just like with the AC and DC voltage measurements, which I covered in the last two sessions, you get to the resistance meter or the ohm meter within the digital volt ohm meter, which is item 1 on the copper measurement screen. Last time I showed you some short ways to navigate the screen by using the right and left arrow keys. This time I'm just going to press the F1 soft key located just below the word display at the bottom left hand side of the screen. You can either scroll to the corresponding number with the up and down arrow keys and press OK, or you can just press the corresponding number on the keypad dialer. We're going to be taking continuous readings of resistance over time, so you'll want to press the number that corresponds to resistance, continuous. The resistance measurement is typically performed with the battery removed. Now, just like with the AC and DC volts or with any of the copper testing measurements, you can press the F1 button and enter a dedicated number to drop battery if you have such a number available to you. First though, let's talk about how an ohm meter works. An ohm meter places a DC battery across the test leads that are being measured. If it sees any continuity path, current will flow from one side of the battery through the continuity path back to the other side of the battery. And when current flows in an analog meter, it moves the needle. Here are some differences, though, between the typical analog resistance meter and the HST 3000. First of all, since the resistance meter is basically a DC battery, it would be helpful to know that the HST has two different settings for the applied battery. In the standard results range, the ohm meter is applying battery of 30 volts DC. If you select soft key number 4, the 30 volts DC is transformed into 120 volts DC. The idea here is that the 120 volts will look harder for a resistive connection across tip and ring, or from either side to ground. Sometimes, though, the higher applied battery will actually make the fault go away. Some people refer to this as drying the fault out, so I always make it a practice to check at low applied battery first, and then high applied battery for my resistance readings. I often ask technicians if they ever encounter a fault with their analog meter where, say for example, the line shows where there's a ground on one side, but when they switch polarity with the meter, the ground goes away. The polarity switching is often done with a switch on the side of the analog meter called a reversing switch, which actually reverses the polarity of the internal battery of the meter so they can see it. I call that type of fault a diode fault, that allows current to flow in one polarity but blocks current in the opposite polarity. While the HST automatically reverses polarity in the background, so the chance of getting fooled by a diode type fault is minimized, if not eliminated. The HST also has a higher resistance range that it can measure. Most analog meters have a top resistance measurement at 20 megohms. The HST measures orders of magnitude higher than that at 999 megohms. Most analog meters also require a manual switching of scale, whereas the HST automatically auto-ranges and auto-scales across its resistance range. Finally, most analog meters are not very focused on accuracy, especially at one extreme or the other, whereas a digital meter such as the HST must pass all requirements for accuracy and are often pre-tested as part of a laboratory evaluation. The result is that you'll see a much higher degree of accuracy across a much wider range. Passing thresholds for resistance vary between 3.5 megaohms on the low end to 10 megaohms on the higher end when measuring tip to ring, tip to ground, and ring to ground, depending upon how your company sets the passing threshold. Generally, a leakage measurement less than 10 megaohm indicates the presence of a fault that should be located and cleared. Leakage resistance also provides an indication of how well the pair balance, which represents the electrical similarity of the tip and ring conductors, and the ability of the pair to reject noise. Generally, a difference in reading greater than about 35 to 40% between tip and ring, tip to ground, and ring to ground should be considered a fault condition and should be cleared. Aside from just measuring and identifying the presence of a fault, though, there are a couple of other things you can do with a resistance meter. One of them is to determine the distance to a low resistance short. In this case, I have the tip wire twisted together with the ring wire at the far end at an extremely low resistance approaching 0 ohms. Now if I knew the gauge of the cable and I took an ohm reading, I could convert the ohm reading into distance. In this case, my measure is reading 51 ohms of resistance. I know that the cable gauge is 24 gauge or 0.5 millimeter. So if I do the math, that equates to 1,000 feet or about 305 meters of loop resistance, or the distance between the meter and the short. This is a very accurate measurement that is often used for pair qualification. Now DC signals will only take the path where there is continuity for them to take. So if I were to introduce a bridge tap between the meter and the short and there is no fault on the bridge tap, the distance to the short would remain 1,000 feet or 305 meters, and the bridge tap would have no effect. I could even put 10 bridge taps on, and as long as there was no continuity between tip and ring, no current would flow and the distance would still be accurate. We actually provide a distance to short measurement. So if you press the F1 button underneath the word display, you'll see the distance to short as item number 6. Go ahead and select that. You can see here that the HST provides you with the distance to short calculation in large font in the middle of the screen at 1,000 feet. On the bottom left hand side, you'll see the cable gauge, which you can change by pressing the left and right arrows. If you need to change the temperature, do so with the up and down arrow buttons. A couple of rules of thumb that I use for temperature are shown here. Buried cable is generally tap water temperature. Add 15 degrees to that for aerial cable. If it's early in the morning or later in the evening, set your cable gauge at the ambient temperature. Well, that ends this session talking about testing resistance. Next, we'll cover the HST's capacitance and opens measurement. Thank you for your time.